Hi, welcome back to this YouTube channel. In today's video, we're going to look at how to find double integral. If you know you've not subscribed to this channel, please subscribe right now. The subscribe button is down on the video. Just subscribe to this channel and also like the video to help the growth of this channel. Make sure you also spread this on the social media, WhatsApp, Twitter, Facebook, whatever, so that other students like you might benefit from this channel. All right, so let's just get into it. Now we are looking at double integral of this function. So let's quickly get started. Now, if you notice in this particular problem, dy, we have dy dx. So that means we have to first of all integrate the function, this function with respect to y first, before we do the integration with respect to x. So let's evaluate this first. So it's always useful to separate them. So first of all, bring this thing out and evaluate it with respect to what? Y. Okay, now, what is this integral? Now, x is acting as a constant. So the integral of the first function is just integration of polynomial. So it's just going to be x squared y. And the second one would increase the power by 1 and divide by that power. Okay, then we evaluate this at what? Y equal to 1, y equal to -1, right? Look, these are the bounds. So when we evaluate this, that will be x squared times 1 plus 1 cube over 3 minus, when we evaluate it at -1, that will be x squared times -1 plus -1 cube over 3. Now, what does this give us? This gives us x squared plus 1 over 3 minus x squared minus 1 over 3. So when you evaluate this, this gives us 2x squared plus 2 over 3. Okay. Now that we have this, let's now bring it back to the initial problem. So now the question becomes evaluating this integral 4 to, or from the bounds 2 to 4, of this function now, 2x squared plus 2 over 3, okay, the x, okay, with respect to x, right? Remember, we just finished with respect to y. Now, what would be the value of this? So all we need to do is to integrate this, just like we integrated the previous problem. All we need to do is just integrate this polynomial. So that will give us 2x cubed over 3 plus 2 over 3x. Now, we have to now evaluate this at what? X equal to 4, x equal to 2. Now, at x equal to 4, that would give us 2 over 3, 4 raised to power 3, plus 2 over 3 times 4, minus 2 over 3 times 2 raised to power 3, plus 2 over 3 times 2. Okay, so let's evaluate this. So this is 64 times 2, that is 128 over 3 plus 8 over 3. And this is 16 over 3. So 2 raised to power 3 is 8. 8 times 2 is 16. So 16 over 3 plus 4 over 3. So when we evaluate this, I think the first one would give us what? 136 over 3 minus this would give us 20 over 3. So evaluation of this is 20 over 3. And the answer would be 116 over 3. Okay, so that was the solution to that first problem. Now let's move to the second one. So the second one is basically asking us to do this, right? So we use the same technique we've just used to solve this problem. So we are going to do dy first before the x. So that means we single out the part that has to do with dy first with respect to the function. So we need to integrate this first before we plug this back into the initial problem. Now, integration of this is with respect to y, so that means x is acting as constant. So we can actually take x out of this because it's just multiplying the inner function, right? So we can take it out. In the previous problem, notice that we couldn't take it out because there's an addition. So there was an addition between x squared and y squared. So you couldn't take it out. You can only take things out when you have multiplication, okay? So we can take x out and just integrate sine y with respect to y. Now, integration of sine y is what? Somebody's saying it, minus cos y. Okay. So that means we have x times minus cos y. Okay. And we have to evaluate this whole thing at what? Y equal to pi over 2 and y equal to 0. So notice how I'm doing this in a very clean way. Make sure you have this habit as well when you are writing your exams or when you're trying to solve other problems of the same nature, so that you have a clean, smooth solution. So now, what do you have? So this is minus x cos y evaluated at what? Y equal to pi over 2, y equal to 0. Then when y is pi over 2, that is basically minus x cos pi over 2. So put bracket around it, minus x cos 0. Now, cos pi over 2 is just cos 90, and that is, cos 90 is what? What's cos 90? So cos 90 is 0, right? So this part would be 0 minus this part, cos 0 is what? 1. So that will give us minus x. So your final answer is just x. Okay. So now let's bring it back to the problem. So when we bring it back here, so you just have 0 to 2 x dx, right? Because this whole inside has become just x. So integration of x with respect to x in the bounds of 0 to 2, that would give us x squared over 2, evaluated at x equal to 2, x equal to 0, and that would give us 2 squared over 2 minus 0 squared over 2, and that will give us 2 minus 0, which is 2. So the answer to this problem is 2. Okay. Now the last problem, which is integral. So we have integral of x plus root y. I think this is the x dy, right? 0 to 2, 1 to 4. So 0 to 2, 1 to 4. Now we need to evaluate this. Now we have to evaluate it with respect to x first. Now what happens? We just need to again single out the part that we need to integrate first, the x. Now this is just integration of polynomial again. So you have x squared over 2 for the first one, then plus root y times x for the second one. Now we have to evaluate this thing at what? X equal to 2, x equal to 0. And that gives us 2 squared over 2 plus 2 root y minus 0 squared over 2 plus 0 root y. So the second part is 0. This is 0. So the first part is just 4 over 2, which is 2 plus 2 root y. Okay, so that is what the integral comes to. Now we need to just substitute it back into the problem. So we have 1 to 4, integral of what? 2 plus 2 root y, right? dy. So dy is what is remaining. Now, let's just quickly finish the problem here. 2 plus 2 root y dy. So this is just, again, very simple to evaluate. It is a polynomial integration. So this will give us 2y. And the other one, now here, notice that what? We need to write this as what? Y raised to power 1 over 2. So when you integrate this, it will be 1 over 2 plus 1 all over 1 over 2 plus 1, which is 3 over 2. Okay? Then we need to now evaluate this whole thing at y equal to 4, y equal to 1. Now let's simplify further. Since this is just 2y plus 2 divided by 3 over 2 becomes 4 over 3. Okay? 3 over 2. Evaluate this at what? Y equal to 4, y equal to 1. Now, when y is 4, this gives us 2 times 4 plus 4 over 3, 4 raised to power 3 over 2, minus 2 times 1 plus 4 over 3, 1 raised to power 3 over 2. Okay, now this gives us 8 plus 4 raised to power 3 over 2. So you can just evaluate this here. This is just the same thing as saying square root of 4 all raised to power 3, which is 2 raised to power 3, which is actually 8, right? Right? So this is 8. So this is 2 raised to the power 3, which is 8. Okay, and then minus 2 plus square root of 1 is 1. 1 raised to the power 3 is 1. So that's 2 plus 4 over 3 times 1, right? Now let's just do this in a few steps. 8 plus 4 times 8 is 32 over 3. Then we have minus 2 minus 4 over 3 when we expand this. Okay, so that gives us 6 plus 32 minus 4 over 3. So which is 6 plus, what do we have? 28 over 3. Right, so you can, if you like, you can simplify this thing further, so that you have 18 plus 28. So that will give us 1646 over 3 as your final answer. All right, so this is how to solve double integration with a couple of functions. I mean, this could be any function at all. All you need to know is to know how to integrate properly and learn how to also evaluate whatever the integral is at the end, at the boundaries, and then you'll be good to go, right? So this will be the end of this video. I'll see you guys in the next one. Don't forget to subscribe to the channel and click the bell button so that you'll be the first to be notified anytime I upload a new video. See you in the next one.